It is officially the year 2021, and we are going to start with 6.4 and 6.5 today. So there's literally one goal, and it's to be able to prove triangle similarity using angle, side, and side, angle, side. And a lot of this I know sounds familiar because all these abbreviations we've used before, but with triangle congruency. But now we're going to be talking about triangle similarity. Now, first thing I want to remind you, we've already discussed similarity. We did right before Christmas break. So just a reminder, for things to be similar, it means that first, their angles are congruent, and second, their sides are proportional. Okay, now remember, proportional means it's like having equal fractions, okay? And also the symbol for similarity is a little squiggle. That means being similar, all right? So now let's discuss the three ways to prove triangle similarity. First one we have is angle. This is when you have two triangles with two corresponding. Now remember, corresponding means in the same spot. Okay, so just a reminder, that means same spot, same location, are congruent. So if you have two triangles and they both have two sets of congruent corresponding angles, then you can say that those two triangles are similar by AA. All right, next we have side. This is whenever two triangles have three, so it's all of them because the triangle is three-sided, three corresponding sides, and here's the key word, proportional, not congruent, guys. This is the difference between the side we've already worked with. So there's going to be some math involved in these, some actual like number manipulation going on than what we dealt with before. All right, and then side, angle, side means we have two triangles with two corresponding sides, proportional, and the included, now remember, included means it's going to be in between the two sides, included angles congruent. And I'm going to provide you with all kinds of examples, and all the examples you're going to see today in the notes are on the actual assignment on your Google form, okay? All right. Now, I know a lot of students say that I move a little too fast, so what I suggest is whenever I go to the next page, for example, example 1 here, pause the video and write this down, then play the video, all right, so that you can kind of keep up better. So pause it if you need to. All right, here we go. So these are all angle. So what we're looking for here is whether we have two sets of congruent angles. All right, and how do you know if you're going to use angle, or side, or side, angle, side? Well, angle is the easiest one to figure out because you don't know any side lengths whatsoever. If you look at all these examples, we don't know any side lengths. Okay, put that on a minute. All right, so if we look at this first one here, so we have triangle LMK and VUT, and we're looking for corresponding congruent angles. So the first thing I notice is this one here, angle L, is 32 degrees, and I'm looking to see on the other triangle if I have a 32 degrees. Voila, I do, angle U, okay? Now I'm going to see, we also know angle K is 37 degrees. So I want to look on the other triangle. Do we have a 37 degree on that one as well? Voila, we do. So here we go. So because of the fact that these two triangles both have two congruent angles, we can say that they are similar by angle, angle. Just like that. So on your Google form, you're going to have the option of AAA, or not AAA, AA, SSS, SAS, or not similar. All right, all of them are going to say the same thing. And you would just click, okay, this one is similar by AA. Okay? All right, now let's look at this next one. Again, we don't know any side lengths, but a lot of students go, we don't know any angle measures either. But we do. We just have to use some prior knowledge that we know about relationships that occur. For instance, if we look at J right there, this right here, I see a bow tie happening. And we know that bow ties are vertical angles. And we also know, I probably just misspelled vertical. Forgive me if I did. All right, we also know that vertical angles are congruent. And you're like, okay, so we've got one, Ms. Nelson. That's all we've got. No. If you think back to Unit 3, and we talked about whenever we have lines that look like this happening, we have all kinds of angle relationships. Do you remember whenever we talked about corresponding alternate interior, alternate exterior, consecutive interior angles? That's what's coming back to kind of like haunt you right now. So if you notice with these two lines, this would be considered our transversal. We could have also gone the other way if we wanted to. But that means that our alternate interior angles here are also congruent. Okay, so if you see these arrows, that means we're going to have an alternate interior angle situation going on, okay? All right, so we have this set of angles that are congruent for both of them, and this set of angles that are congruent for both of them. Therefore, we are similar by angle, angle. Okay. All right, let's look at this next one here. Now, the one thing a lot of students mess up with problems like these is they're like, I don't see the two triangles. So think of it like this. So like you have a big triangle. See if I can do it. Scissors. It's, craft day. All right, so we have two triangles going on. Okay, it looks a little something like this, right? And what it is it's a big triangle with a little triangle on top of it. That is what's happening right here in this problem, okay? All right, so if we're looking for congruent angles, the first thing I notice is that they share this point, don't they? Both of these triangles share this angle right here. So we know that's congruent because it's shared, okay? They share it. Sharing is caring. All right, now let's see what else do we know. Well, we know this one's 82 and this one's 86. Are they the same? No. We don't know anything about R, and we don't know anything about G, so we only have one angle. Now, is that enough information? It is not, because our similarity theorem here is AA. We have to have two, we only have one, so we would say not similar. Sad day for that triangle. All right, now let's look at this one over here. So again, just like this one up here at the top, the first thing I notice is B. We have a bow tie, which means we have vertical angles. Yeah, I did misspell it. I got it right that time. Okay, and we know that vertical angles are congruent. Now let's see what else we know. We know R has one arc, so I'm going to look to see, is there a one arc over here? No. I have a 2 arc and a 3 arc, and there's not a 2 arc or a 3 arc over here. So we only have one angle. Again, is that enough information? It is not. We have to have two. So this is another not similar. Now, all of these are examples that are on your homework, your Google form, okay? So there's 4 of the problems from your homework. So make sure you're taking notes properly, because then you have 4 of the answers already. That's pretty awesome. All right, let's move on to the next part of our notes. That is going to be side, side, side. All right. Now, this first example, remember how I told you it can be 2 triangles whenever you have a big one with a little one on top? Well, that's what's occurring right here. This time we're just dealing with sides. So what I'm going to do is I like to go ahead and redraw my triangle, and put my sides on there. So my first triangle I have here is GCB. All right. Am I missing part of the information on that one? I'm missing this right here, but I know it. Hold on, let me pause this and find the worksheet and fix this issue. Voila! Ta-da! Fixed it. Okay. And I'm almost about to run out of time, so this will be a two-parter. All right, so this one here, we have a length of 26 over here. We don't know this one, but we can find it. We just take 49 minus 29. This is going back to like Unit 1. Remember when we were doing segment addition problems? So we do 49 minus 29, and we get 20 over here. And again, we don't know this one, but we can find it because we have 42 minus 23, and that gives us 19. Okay, now for my next triangle, the bigger one, that would be triangle GFE. Well, we have 42, 49, and 63. So this is going to be the last example I'm going to do for you in part 1 of this video. Okay, so one of the tricks I like to always remember, just to kind of help me out on doing all these proportions, is I always like to go from small to large. From small to large. So I list all my sides from smallest to largest. So like with this first triangle here, what do we have? 19, 20, and 26. All right, and this one here we have 42, 49, and 63. And you're like, okay, well, what are we doing with that? Well, what we want to know is, are these equal? Okay, that's what we want to know. Calculators will assist you. So 19 over 42. Okay, and they have to be exactly the same. So let me turn this on so you can see it. All right, and then 20 over 49. Uh-oh, can already see a difference here. This one goes 0.545, this one goes 0.40, so we already know these are not the same, okay? And then if we did 26 over 63, no, these are not the same. And if they're not equal, that means that we are not similar. Okay, so in part 2 of your notes video, I'm going to be picking up here on this bottom example that we're going to do, and continue on with side angle side. So, see you in a little bit.